This is the last video on derivations of reduction formulas. This will be a reduction formula for the sine to any power. So we'll write the integral of sine to the n of x dx as the integral of sine to the n minus 1 of x multiplied by sine of x dx. My previous video, we have seen how to choose your u. Also, we'll use the integration by parts formula. We know how to choose our u, we know how to choose our v. So this inverse trigonometry I, this is trigonometry. From our formula, we said these are logarithmic functions, these are inverse trigonometric functions, these are algebraic functions, these are trigonometric functions, these are exponential functions. So from our integral, we have an inverse trigonometry. It starts, so automatically this will be our u. Again, so this is trigonometry, it follows, so these are dv. Okay, so let's compute let's write the integration by parts formula. It says when you're integrating u multiplied by dv, your answer is u multiplied by v minus the integral of v multiplied by du. So as for now, we have our u, we have our dv, we have our u, we don't have our v. So let's compute our v, let's compute our dv. So from the formula, from the information we have, we have our u as that. So our u equals to sine to the n minus 1 of x. So let's find our du, that's the derivative. So derivating u with respect to x, we get multiply the power, so n minus 1 multiplied by the function itself, a to the n minus 1 to the power, so it will be n minus 2 of x multiplied by this now chain rule, multiplied by the derivative of the sine of x. So that is cos of x. With respect to x, it will be dx. We have our dv. Our dv is sine of x. Our dv is sine of x dx. So our v is the integral of sine of x dx. We'll get our v as negative cos of x. Substituting inside the formula, so we'll get our integral. Let me change the color. So we'll get our integral of sine to the n minus 1 of x multiplied by sine to the x dx equals to our u. What's our u? Our u is that sine the n minus 1 of x multiplied by our v, negative cos of x minus the integral of our v here, negative cos of x multiplied by our du. This is our du, n minus 1 multiplied by sine the n minus 2 of x multiplied by cos of x dx. The next step is to split the integral into 2. So we get the integral of sine the n minus 1 of x multiplied by sine the x dx as writing negative cos of x. So we'll write sine to the n minus 1 of x multiplied by sine of x dx equals to negative cos of x multiplied by sine to the n minus 1 of x minus, we split the integral into 2, minus the integral of negative cos of x. Sorry, we don't, for now, let's not break. From here, there's cos of x multiplied by cos of x. cos of x multiplied by cos of x, cos of x multiplied by cos of x is the same as cos squared of x. From the Pythagorean identity, we have a Pythagorean identity. Let me write here. That says that says cos the second of x plus sine squared of x equals to 1. So we'll have to replace our cos. Let me just from here, let me write negative cos squared multiplied by n minus 1 of sine to the n minus 2 of x dx. So this cos squared of x will replace, what's cos squared of x? Cos squared of x is the same as taking sine to the right side. Cos squared of x is the same as 1 minus sine to the x squared. So let us write the integral of sine to the n minus 1 of x multiplied by sine of x dx will be equal to negative cos of x multiplied by sine to the n minus 1 of x minus the integral of negative, but now what is cos squared of x is the same as 1 minus sine squared of x multiplied by n minus 1 multiplied by sine to the n minus 2 of x dx. Okay, let's take, these are n minus 1, it's a constant term. Let's take it outside the integral. Again, we'll get the integral of sine to the n minus 1 of x multiplied by sine of x dx equals to negative cos of x multiplied by sine n minus 1 of x minus. Okay, let's take these outside the integral. Then, okay, so it will be n minus 1, open up that large bracket. Everything inside the integral will be the integral of negative sine, negative into, okay, let me just open this like negative of 1. Let me open this bracket. It will be negative 1, negative 1 multiplied by negative, it will be positive, plus sine squared of x. Okay, close the bracket, multiplied by this sine to the n minus 2 of x dx. Okay, allow me to so from here, there's this other bracket here. So from here, let's open our bracket. So we'll get the integral of sine to the n minus 1 of x multiplied by sine of x dx equals to negative cos of x multiplied by sine to the n minus 1 of x minus the integral of, it's minus n minus 1 inside the integral of, let's open this bracket, so it will be this multiplied by negative 1, so it will be multiplied by negative sine of n minus 2x, okay, plus this multiplied by this will be sine squared of x multiplied by sine to the n minus 2 of x dx. From here, let's split the integral into 2. So we'll get the integral of sine the n minus 1 of x multiplied by sine of x dx equal to negative cos of x multiplied by sine the n minus 1 of x. Let's split into two integrals, minus n minus 1, the larger bracket. Splitting into two integrals, we'll get the integral of negative cos, negative sine of n minus 2x plus dx plus the integral of sine squared of x multiplied by sine the n minus 2 of x dx. So so it will be sine multiplied by sine second multiplied by, so after splitting inside the integral, open the bracket. So this is minus, open this bracket using this, so open the bracket, so we get the integral of sine the n minus 1 of x multiplied by sine of x dx equals to negative cos of x multiplied by sine of n minus 1 of x minus this multiplied by this will be it will be minus n minus 1 multiplied by this integral, so it will be minus the integral of sine. So this is minus, again this is minus, so it will be negative, with the negative it will be positive, so it will be plus the integral of sine the n minus 2 of x dx. This multiplied by this, negative multiplied by positive will be negative, minus n minus 1 inside the integral of sine squared of x multiplied by sine the n minus 2 of x dx. From my previous video, we saw this. So sine to the squared multiplied by sine, adding these powers will get n. Again, n minus 1 plus sine raised to 1, so this again will be 1. So this expression is the same as this, so we'll have to add our coefficients. Adding the coefficients, taking this to the left side, taking this to the left side, and adding the coefficients, we'll get the coefficient here is n minus 1, negative n minus 1. So taking it to the left side, the negative changes to be positive, so it will be n minus 1 plus the coefficient for this is 1. So it will be n minus 1 plus 1 plus 1. Our value is n. So we want so it will be n, the integral of n multiplied by the integral of sine, the n minus 1 of x multiplied by sine x dx equals to negative cos of x multiplied by sine the n minus 1 of x plus n minus 1 the integral of sine the n minus 2 of x dx. We want the integral of sine to the n minus 1 multiplied by sine to the, which is the same as sine to any power of x. So divide by n, divide here by n, all this expression divide by n, again this divide by n. So our final answer becomes will be this n goes with this, so we get the integral, which we can replace with I, the integral of sine the n minus 1 of x multiplied by sine to the x dx, same as negative 1 over n cos of x multiplied by sine the n minus 1 of x plus n minus 1 over n multiplied by the integral of sine the n minus 2 of x dx plus a constant c. So this is the reduction formula for sine. Given any example, for example, sine raised to the 5th power, it's easy to compute this. So replace n, it will be negative 1 over 5 multiplied by cos to the x multiplied by sine. So n replace with 5, so it will be 5 minus 1, it will be sine to the 4th, and so on. So we have cleared all the videos on reduction formulas, so it will be easy to compute any power of the trigonometric functions. Don't forget to subscribe. Thank you.